Hello there. Today I'm going to give you a quick demo of Magic XPA running in a Docker container. Now, there's nothing new about Magic or Linux or Docker, but the combination of all three for most of us is, in the words of the poet Madonna, all shiny and new. I'm just going to walk through what is working for me. It's not best practice, it's just what I did to make it work. I'm still exploring too. I'm going to show you some simple HTML marriage programs that are accessing cloud databases. In each case, it's just a simple list program. So let's get started with the demos, then I'll get into the code and the configuration. So I've got Magic running locally in a Docker container, and it's serving up this landing page. And from here, I'll show you database connectivity to SQL Server, PlanetScale, and Vercel. Let's look at each of those in turn. So here, nothing fancy, but I've got data from a SQL Server database that's in Azure through Magic merged into a web page. I've got something similar here. This time the data lives in a MySQL database that's on PlanetScale. So that was using the MySQL gateway. Just to prove a point to myself, I also used the ODBC gateway to get that same data back from PlanetScale. Finally, here's Vercel. There's a Postgres database, same deal. I've got a marriage program presenting it in a browser. For today, I'm not going to get into too much detail about the cloud databases that I'm using, but let me show you where that data actually lives. So SQL Server, you can see here in SQL Server Management Studio that I'm connected to a virtual machine where I've got the database running, and I had a simple tasks table that gave me the data behind the marriage page that Magic created. Similarly, for PlanetScale, I've got a MySQL database with the table that supplied the data. Let me quickly show you that. And Vercel hosts Progress databases, and I also set up a database and table there with exactly the same data. Now let's have a look at the Magic application that's behind all of this. So I've got an application called MGWeb. In the data repository, I've got an entry for each of the tasks tables that I used across the hosting providers, so PlanetScale, Vercel, SQL Server. In the program repository, I've got a separate program for each of the demos that you saw. Let's have a quick look at the SQL Server tasks demo. You can see that the data view merely defines the tasks that I'm using, brings back the task ID and title. The record suffix does a merge to a merge form. Here I have a template, and I'm simply merging in the tags, one in the header that says what I'm actually accessing, and the ID and title that you saw for each row. Very simple. And I do exactly the same across the other tasks. So let's finally get into the guts of the thing, and we'll take a look at the Docker configuration. Now, my solution still follows the magic separation of build and deployment into image build and container deploy folders. However, I have made some significant changes. Now, I'll share all of this before too long in a GitHub repository, but for now, let's have a quick walkthrough. So in image build, we have a Docker Compose YAML and a Docker file for each of the images, an app server image and a web server image. Now, I've chosen not to have a zip file to get the assets from my machine into the image during the build process. Instead, I've expanded everything into a deploy folder, which for me just made it easier to manage and separate. All right, so let's have a look at the .env file that we've got in the image build folder. And this lets us supply arguments to the Docker Compose process that builds the app server and web server images. So I've added some new things in here. For example, I wanted to control what was added to the image. So I need Python. It's Linux. There's no C sharp snippets. There are no Windows DLLs to call. So when I want to do something sexy and funky, I'm going to drop to Python to do that. I wanted to control which of the database drivers were installed. So I've got switches to control whether I install MySQL, Postgres, SQL Server, TDS, and the Unix ODBC manager itself. I also have arguments for where those new packages are actually located. All right, on to the Docker Compose YAML. You can see that I reference all of these new switches that I've introduced. They're passed as arguments to the Docker file that builds the app server. If we look into that, you can see there's a whole bunch of conditional operations that happen that determine whether or not, for example, whether I'm installing the MySQL client driver, whether I install Postgres, whether I install the SQL Server client driver, the free TDS ODBC drivers, the Unix ODBC manager, and Python. There's a whole bunch of stuff that needs installed for that to work, all based around whether or not I've set that argument. There is something similar going on with the Docker file that builds the web server, basically letting it know where the source and target folders of all of these assets are coming from and going to. Let's take a quick look at some of the stuff that makes ODBC work under Linux for Magic. So, for example, I have a new ODBC INI that I copy into the etc directory, which just sets up a DNS for PlanetScale, for PlanetScale ODBC, for SQL Server. There's a new MGENV file where I tell Magic, hey, I want you to use MySQL or Postgres or ODBC. Those drivers aren't installed by default. And the Magic INI that I'm using is also copied in place. And it's here that I'll define the new databases that I've added. For example, PlanetScale, Vercel, and SQL Server you saw me use. So you can see my username and passwords here. Don't worry, I'll change this before I release it. Now, the build process also relies on other assets that I have in a deploy folder. There's an app folder, a web server folder, www folder. The app folder contains the Magic application itself, any of the merged templates that I've used in the application. The web server folder is unique to what the web client application might use, and the www folder contains information, HTML files, images, whatever, copied into the root of Apache. Now, if we come to look at the container deploy side of things, there's not too much complexity going on there. We still have a .env file where we have the external port and address defined, a requester alias that I added in just for a little bit of fun, the license file we're using, the additional INI that we're supplying to Magic at runtime, that kind of thing. If we look at that additional INI, regular Magic INI, whatever we need and want to make the application run, the Docker Compose simply brings all of the images together. The app server deploy, Docker file, it's kind of simple. The web server deploy, nothing going on except that we update the server requester and the requester alias in a couple of different files, the server config JSON and Apache's HTTPD conf file. That's it. Okay, let's build and deploy. Build is done. Let's deploy. So we're just deploying locally. In time, I'll do a demo where I deploy to Azure, AWS Fargate, all of that good stuff under Kubernetes, maybe to FlyIO. Here we are just locally to see it work. Okay, we're done. So let's see this run in a web browser. So we're running on a local host. The Docker container is exposed to the host machine on port 8000. Here we go. This is just the entry application that I built. Very simple. So really, that's all I have for you today. Hope you had some fun. I just remind you that as a freelance consultant, I'm available for weddings, bar mitzvahs, and all those really cool magic projects where you just need somebody to show up and get the job done. See you next time.